So look at this problem. X and Y are jointly normal random variables with variance equal to with common variance sigma x squared, but correlation coefficient equal to rho, not equal to 0. So they are dependent random variables. So what we are interested is figuring out the expected value of the absolute value of xy. Notice that expected value of xy is really easy. This is simply uh, rho sigma x sigma y. So that's simply rho sigma squared. So what we are interested is what happens, how would this result change? Of course, this is the same as expected value of x multiplied by absolute expected value of the absolute values of x and y. So I'm going to derive this result. So to start with, we have the joint density function to be 1 over 2 pi sigma squared, square root of 1 minus rho squared, e raised to minus 1 over 2, 1 minus rho squared, x squared minus 2 rho xy plus y squared over sigma squared, common sigma. So we can try to use this the definition, the basic definition, and simply have to just go through a lot of simplifications. So this is going to be 1 over 2 pi sigma squared, square root of 1 minus rho squared, absolute value of xy minus infinity to plus infinity, e to the power minus 1 over 2 sigma squared 1 minus rho squared, and in the numerator x squared minus 2 rho xy plus y squared. So here I'm going to make a change of substitution, x equal to r cos theta and y equal to r sin theta. So that dx dy dx dy would turn out to be r dr d theta. Just the 2D Jacobian from a polar coordinate transformation. So with this, I'm going to substitute this here. So r goes from, as x and y cover the whole plane, r goes from 0 to infinity, theta covers the whole circle. So this is the expected value of xy would be the constant 2 pi sigma squared 1 minus rho squared. So r goes from 0 to infinity, theta goes from 0 to 2 pi. X is, so xy will be r squared cos theta sin theta. Then e to the power minus x squared will be r squared cos squared theta plus r squared sin squared theta. So if you substitute for x and y, this will come out to be 2 rho sin theta cos theta divided by 2 multiplied by 1 minus rho squared sigma squared r dr d theta. So to simplify this further, we can call this whole quantity to be one variable. So I'm going to call r squared multiplied by, so if you wish, if you notice that you can also see that this is rho sine 2 theta. So I'm going to call r squared multiplied by 1 minus rho sine 2 theta divided by 2 sigma squared 1 minus rho squared to be u. And this gives du or two, from here 2r dr. And so I'm going to do 2r dr multiplied by 1 minus rho sine 2 theta over 2 sigma squared 1 minus rho squared to be du, or r dr to be, that gives r dr to be, so notice that 2 cancel, so sigma squared multiplied by 1 minus rho squared du divided by 1 minus rho sine 2 theta. So I'm going to substitute it here, so which gives expected value of the absolute value of xy to be 1 over 2 pi multiplied by 1 minus rho squared integral. So this would become, so instead of r squared, I'm going to also substitute from here. R squared would be, r squared is u, so r squared is, here we have r squared, so r squared is 2 sigma squared 1 minus rho squared u divided by 1 minus rho sine 2 theta multiplied by cos theta sine theta. Then you have this quantity, that's simply e raised to minus u, and r dr is this quantity. So I'm going to substitute that to sigma squared 1 minus rho squared over 1 minus rho sine 2 theta du. So notice that u term is only u e raised to, so there are two integrals, 0 to infinity, 0 to 2 pi. So I'm going to collect all the terms. Notice that this denominator is the same. And here you have, so let's see, so you have sigma squared here. There was a sigma squared here. So this sigma squared cancels with this. So we have 1 minus rho squared cancels here. This is 1 minus with a square root here. So you have 1 minus rho squared, 1 minus rho squared. So, and here you have a square root. So in the numerator you have sigma squared multiplied by 1 minus rho squared to the power 3 by 2 over 2 pi. And here 0 to 2 pi. This, if you want, you can write sine 2 theta. So this is simply sine 2 theta, because 2 sine theta cos theta absolute value, and divided by 1 minus rho sine 2 theta, the whole squared d theta multiplied by 0 to infinity u e raised to minus u du. This is easy. This is 1. So basically we need to evaluate this integral. And that's what we are going to task now. But the big task is doing that integral. So because this is because of the symmetry, this integral 0 to 2 pi, because of the 2 theta here, this is going to be, essentially it goes to 4 theta. So this is 2 times the integral from 0 to pi. So expected value of xy absolute value of xy is 2 times, so 2 cancels, giving us pi. So we have sigma squared 1 minus rho squared to the power 3 by 2 divided pi integral 0 to pi absolute value of sine 2 theta divided by 1 minus rho sine 2 theta squared d theta. Look at the last line. I'm just copied that because of this integrals. And so let me concentrate on this integral. I'm just not going to carry this constant all over. So I'll ultimately come back and substitute it here. So we are going to evaluate 0 to pi sine 2 theta divided by 1 minus rho sine 2 theta squared. First, I want to get rid of this absolute value. So I'm going to put it from 0 to pi by 2 and then from pi by 2 to pi, the same integral. So remember 0 to pi by 2, this is goes from 0 to pi. So absolute is positive, so that you don't need the absolute value there. And here it is sine absolute value of 2 theta divided by 1 minus rho sine 2 theta squared d theta. And you can see here, in this case, this will be negative, so this becomes positive. So the easiest way is define phi to be pi by 2 minus theta. So you can see when theta goes from, or the other way, phi is theta minus pi by 2. So notice that so 2 theta is pi plus phi. So this will become sine 2 phi, and this will become minus sine 2 phi. And so this will become plus. So d theta is d phi. And if I change it back to sine, then you can see that, all right, so the limits are when this is 0 to pi by 2. So I can combine this as 0 to pi by 2 sine 2 theta, because this will remain as positive. This is 1 over 1 minus rho sine 2 theta, the whole square, plus 1 over 1 plus rho sine 2 theta, the whole square, by that symbol change of d theta. By here, this would become minus sine 2 phi, minus minus plus. So if you combine the numerator terms, this becomes notice that this and this with the plus sign. So you get rid of the middle term, and the constants come twice. So this is 0 to pi by 2 sine 2 theta multiplied by 1 plus rho squared sine squared 2 theta divided by this multiplied by this. That's 1 minus rho squared sine squared 2 theta, the whole squared d theta. So we need to evaluate this integral. So one more time, I'm going to make one more change. I'm going to call the 2 theta to be phi. So d theta is d phi by 2. So the 2 cancels. So notice that as theta goes from 0 to pi by 2, phi goes from 0 to pi. So this becomes 0 to pi sine phi 1 plus rho squared sine squared phi divided by 1 minus rho squared sine squared phi the whole squared d phi. So this need to be evaluated. And so now if we want, we can, not to lose this constant, I'm going to substitute that and start there from the next page. So this is expected value of xy turns out to be sigma squared 1 minus rho squared to the power 3 by 2 or pi 0 to pi theta or phi. I'm just going to change back to theta. So 1 plus rho squared sine squared theta d theta. So this need to be integrated. So if you want the numerator, just to make a cancellation here, 1 plus rho squared sine squared phi theta can be written as 2 minus 1 minus rho squared sine squared theta. So 2 minus 1, so you get back this. The idea is that so that you can cancel this, and the 1 plus rho squared sine squared theta over 1 minus rho squared sine squared theta, the whole squared becomes now 2 divided by 1 minus rho squared sine squared theta minus 1 over 1 minus rho squared sine squared theta. So we can substitute this here. So that expected value of xy becomes sigma squared 1 minus rho squared 3 by 2 pi and then two integrals. So they are 0 to pi. You have a 2 sine theta divided by 1 minus rho squared sine squared theta d theta minus 0 to pi sine theta d theta divided by, here there is a 2, 1 minus rho squared sine squared theta the whole square. So we'll have to consider this 1 by 1. So before I go, you can use a standard procedure. If you write sine squared as 1 minus cos squared, you can see that there's some simplification. So I'm going to write this as both the places 1 minus cos squared theta. And so then you can see the result is sigma squared multiplied by 1 minus rho squared 3 by 2 over pi. Then this is 2 integral 0 to pi sine theta. So that's going to be 1 minus rho squared plus rho squared cos squared theta d theta minus integral 0 to pi. Same thing, 1 minus rho squared plus rho squared cos squared theta squared d theta. So the substitution is clear here. You substitute cos theta equal to x on both the places. Then sine theta d theta, the numerator will become dx. So we can simplify this as sigma squared multiplied by 1 minus rho squared over 3 by 2 pi integral 2 times. Look at the limits now. When So cos theta equal to x, I'm sorry. So minus sine theta d theta is dx. So when cos theta is 0, this is the lower limit is 1, pi upper limit is 0. With the minus 1, the limits will flip. So this is 0 to 1. Sine theta, cos theta is minus sine theta cos theta is dx. So this term will come first. I'm going to put this term first. So this is 0 to 1. This is dx over 1 minus rho squared plus rho squared x squared the whole squared minus integral 0 to 1 minus rho squared plus rho squared x squared dx. So this need to be evaluated. And we have two terms here. So I'm going to take up term by term. And you can see the procedure is clear. It's a constant plus x squared. So we can use the tan theta transformation. So I'll come back to 3 here. So I'm going to deal with one by one of those expressions to simplify. So the second expression is 1 over integral 0 to 1 over 1 minus rho squared plus rho squared x squared. I'm going to pull out the constant outside. So this reads now 1 minus rho squared. So this should be 1 minus rho squared square root here. So let me substitute rho over square root of 1 minus rho squared x to be tan theta. So that dx would be square root of 1 minus sigma squared over rho 6 squared theta d theta. So this now reads 1 over 1 minus rho squared. And this is going to be 1 plus tan squared, that's 6 squared in the denominator. In the numerator is going to be 1 minus rho squared over rho. Then you have 6 squared theta here. Here you have 6 squared theta d theta. This goes from 0 to... All right, let's look at the limits now. When x is 0, tan theta is 0. When x is 1, so the upper limit is tan inverse of rho over square root of 1 minus rho squared. So that's, if you look at that, that's the same as sine inverse rho. So here so this will turn out to be 1 over square root of 1 minus rho squared multiplied by rho here, 0 to sine inverse rho. Easiest way is you call this to be some quantity. So tan of x is rho over 1 minus rho squared. And you get sin x to be rho, sin x to be rho, or rho or x is sine inverse rho. So this is the same as sine inverse rho if you want. And this is simply theta. So this is simply sine inverse rho. So we got the one integral. So notice how complicated this whole thing is. So I'm going to call this 4. Later I'll substitute this into the expression 3. And now going to the other integral, sort of similar way, 0 to 1 dx over the square of this 1 minus rho squared plus rho squared x squared the whole square. So again, if I exactly use the same substitution, I can just cut it short and write the expression here. 1 over 1 minus rho squared the whole squared goes outside. This is 0 to tan inverse or sine inverse rho over 1 minus rho squared, which is the same as sine inverse rho. So exactly the same thing. And here it is rho over square root of 1 minus, or the other way, 1 minus rho squared square root over rho. And here you have, because of the square, denominator is secant of 4 theta, and numerator is secant squared theta d theta. So 1 over secant squared comes out. That's cos squared theta. So which I'm going to write it as 1 plus cos 2 theta over 2. So let me simplify these things. So this is turns out to be 1 over rho multiplied by 1 minus rho squared to the power 3 by 2, 0 to sine inverse rho. Remember, this is 6 squared goes, you get cos squared here too, which is 1 plus cos 2 theta divided by 2, which is what I'm going to substitute it here. So 1 plus cos 2 theta divided by 2 d theta. So this will turn out to be the 1 over rho multiplied by 1 minus rho squared 3 by 2. So the first integral is simply d theta, theta, top limit minus bottom limit, you get sine inverse rho. And the second limit is cos, notice there is a 2 also here, so I'm going to pull out the 2 here. And the second one is cos 2 theta, that is sine 2 theta divided by 2. And so that will turn out to be sine of sine 2 theta divided by 2. So that's with a plus sine 2 multiplied by theta is sine inverse rho divided by 2. So to simplify this, sine 2 theta, we can expand it as, so let me just expand it here. This is sine 2 sine 2 sine theta cos theta. So 2 sine of sine inverse rho, that's a sine rho, multiplied by cos of sine inverse rho. So this is just a rho. This, if you work out, again, this is going to be square root of 1 minus rho squared. And there was a 2 here, so 2 cancels. So this answer turns out to be so notice that so this answer, let's write it down. This is 1 over 2 rho 1 minus rho squared to the power 3 by 2. I think we have all the terms, sine inverse rho plus rho square root of 1 minus rho squared. So that's the answer to the second integral. I'm going to call it 5. So I'm going to put 4 and 5, substitute 4 and 5 into 3. So that's going to be, so let's go to 3. 3 was, you have these two integrals. So remember, if you look here, you have a 2 here. So I'm going to, so this will get multiplied by 2. These two will cancel. And the other one is minus of this. And that's the 4. 4 is here. So I'm going to substitute these results into 3. So you get expected value of xy is sigma squared 1 minus rho squared to the power 3 by 2 over pi. So notice that. So this is the expression 3. I'm going to substitute for this term. I'm going to take this result and multiply by 2. This is number 5. So I'm going to multiply that by 2. So that's going to be simply 1 over a rho square root of, so I'm going to write expected value of xy, absolute value, sigma squared. Now number 5 is multiplied, number 5 is here, that's multiplied by 2 because there's a 2 here, so this 2 will cancel, then it's going to be 1 over rho 1 minus rho squared to the power 3 by 2 multiplied by sine inverse rho plus rho square root of 1 minus rho squared. And then the other term minus this, which is this. So the denominator is the same. I just have to minus sine inverse rho. So notice that in 4, you only have square root of 1 minus rho squared, whereas here it is 3 by 2. So this should be 1 minus rho squared, the sine inverse rho. Because this 1 minus rho squared will cancel here, and you will get the rho multiplied by square root of 1 minus rho squared. So that will give us, notice that here sine inverse will cancel. Let me just make sure. So this is going to be, and here this cancels out. So you get sigma squared over a rho pi minus minus plus. So rho squared sine inverse rho plus rho square root of 1 minus rho squared. So if I cancel the rho, you get the result to be sigma squared over pi square root of 1 minus rho squared plus rho sine inverse rho. This is expected value of xy, absolute value of xy, compared to expected value of x. This should be compared with which is a breeze, simply rho sigma x sigma y, which is just this. So you can see the additional effort involved in the computing the absolute moment of absolute value of x, y. So one way to interpret this is if x and y are complex, then that represents the cross magnitude, the absolute value of x, y. So this is the distribution of the magnitude of the cross term x, y. Okay.